All right, Remington, we started without you, and then thankfully you'll have to thank Ethan because he was like, hey, Remington's gone. You need to record. Okay, whoops, sorry. So we are back on this page. We are filling in some of the missing pieces. So what we did so far was we wrote in and named this triangle ABC. Then we called these points D, E, F, and then we put G here as this guy in the middle. So label that. That is for this top left box. We're still under circumcenter. And then what we did was we put these little red lines in here. We connected them back to the vertices, okay? Now, all right, are you guys ready? We got to add stuff into the bottom here where it talks about congruent parts. What's it mean to be congruent? The same, okay. So even though, are you guys listening? Are you ready? Even though this line and this line and this line, those ones are the ones that we originally drew with the perpendicular bisectors, those are not the parts that are the same. What is the same? Yep, GA is the same as GB, which is the same as GC. These little loops right here are all going to be the same length, okay? Those weren't the original lines that we drew, but those are the parts that are going to be the same length, right? It kind of makes like a fan all the way around, okay? All right, we're going to go over to in center and do the same thing. I got to erase some stuff. Can I move over? Go to in center. Okay, I want you to name these A, B, C, and then we have to draw these lines. I'll help you do that here in a second. Let me get rid of them. Okay, so name your vertices A, B, C. You should have this many lines drawn right now. Oh, we called the middle M. We'll call him G, if that's what you want to call him. Okay, there's my in center. All right, when we go to make these lines, okay, this guy is not the same as this one, is not the same as this one, even though those are the original lines that we drew. Those are not the same length, okay? But what we need to do is we need to take this guy and we need to connect him back to the side at a 90-degree angle, okay? This pink one is not at a 90-degree angle. You need to connect him straight down. So you might have to rotate your paper around so that you can see this. And we're going to put a dot right there, okay? I'm going to do the same thing here. If I turn this so this is like the bottom of my page here, it might be easier to see and connect him straight down. I think straight down is going to be like right there-ish, and that makes him a 90-degree angle, okay? Same thing here, straight down would be like there-ish. Those are going to be my 90-degree angles, okay? So I'll call these guys D, E, F, and G is that middle one. These red lines that we just drew, those are all going to be the same length. Those aren't the original ones that we drew, but those are all going to be the same length. Got it? So DG, EG, FG, those are all going to be my congruent pieces. Okay, we drew the angle ones, but when we connect them back to the sides, those are going to be the same length. Got it? Okay. Now, one question. Is F a bisector? Does it split the bottom side into two equal pieces? No. I mean, no, not at all. Like, though, that doesn't even look the same, right? Okay, so keep that in mind that when we're doing that, he's not a bisector, right? This is bisecting just the angle, not the side. Got it? Okay, let's go to this one. We're talking about centroid here. I'm going to erase all this stuff from this morning. And out of the 4 that we're going to do, we're going to save orthocenter for tomorrow. But out of the 4, this one's my favorite because it's like a little puzzle. Okay, so here we go. Centroid. Here's how you create the centroid. You make him from, I'm going to say made, from something called a median. Have you guys heard of like mean, median, mode, range? Yeah. Median means like the middle, right? Okay, so here's the deal. When we say median, I'm going to talk about like this bottom side, and we're going to do the median of the bottom side. Let's name him ABC again, okay? If I find the middle of the bottom side, I'm going to put that dot right there, okay? That's the middle. I kind of eyeballed that. You can measure him if you want to, but I eyeballed him, okay? That's the middle. All right, now, if we were going to do a perpendicular bisector, I would draw him straight through, and that would be a 90-degree angle, but don't do that, okay? The difference here is we found this median. Those are 2 tick marks. We've got him in the middle exactly, and instead of making him straight up and down, I'm going to connect him to the opposite vertex. So he is separating this bottom side exactly into 2 equal pieces, and he's connected back to the vertex. Here's my magic question for you. Are you ready? Is this angle split in half? Is he cut into 2 equal pieces? Is this side of the angle the same as this side of the angle? You think so? It appears like it is, but it's not. So it has separated the bottom into 2 equal segments here, but it is not separating that angle into 2 equal pieces. So you cannot assume that these are the same. Okay, you'll see it. It'll be a little bit more obvious when we do another one. Okay, so let's find the middle of this guy right here, and let's connect him back to the opposite vertex. Woo. Okay, he does look like he separated him into 2 equal pieces, but it's not. The only thing that's equal is these 2 segments right there. Okay, if I do the same thing for A, I'm going to split him in half, and I'm going to connect him back to A. Woo. And again, these 2 pieces are the same around the edges, but these 2 angles are not necessarily the same. Now, what would have to happen in order for those angles to be the same? These two angles are not the same. Is there a certain circumstance where I would draw the median and they would be the same? If it's an equilateral triangle, then it would separate your angles into be the same. Actually, the fun thing is, are you ready for this? If we have an equilateral triangle, your circumcenter and your incenter and your centroid will all be in the same position if it's an equilateral triangle. Does that make sense? Because it will bisect the angles and the sides at the same time and all that good stuff, okay? So, just a fun fact, if we're dealing with an equilateral triangle, that's how that works, okay? Your centroid is this dot right here where they intersect, okay? The median is the vertex to midpoint. So you take the midpoint to the side and connect them to the vertex. Vertex to midpoint. That's what a median is. That's what a median is. Okay? Good? That's what the centroid is. Now, they don't really have congruent parts, but he has a special thing that happens to him. And this is my favorite. Okay? Some special things that happen. Are you ready for this? Each median, I'm going to focus on like this one right here. That one that goes straight across there. The way that this works is your median. Each median has like that centroid that's in the middle of it. It separates it into 2 pieces, right? This guy and this guy. You see that? Those are obviously not the same length. But what is always true is that the longer one is double what the shorter one is. Always. Okay? So let me go to this other one. Let's talk about this one right here that goes this way. If this is 2, this is going to be 4. Okay? All right, now let me make it a little harder. Let's talk about this one going up and down. Let's say the whole thing is 9. How long is this and how long is this one? Yeah, 3 and 6. Do you see how that works? The longer piece is double what the other one is. Okay, so here's how you do this in your head if you can't figure it out by like just mental math. Okay, if 9 is the whole length, it's kind of like it's separated into 3 chunks. This is 2 of the chunks and this is 1 of the chunks. So if the whole thing is 9 and I divide it by 3, the smaller one is that amount, the longer one is double that amount. Okay, 9 divided by 3 is 3, that's the small amount. If I double that, it's 6, that's the bigger amount. Does that make sense? Okay, what if the whole thing was 12? How much would the small one be? 4, and the bigger one would be 8, right? Like, does this make sense? Okay, so that's how the centroid piece works, all right? So I'm going to say the longer chunk, because I don't know how to better describe this. The longer chunk equals 2 times the smaller chunk. It's kind of like a puzzle piece that it fits together. So when you're drawing your centroids from the vertex to the middle, where that centroid separates them into pieces, the longer side is double what the other side is, okay? It's like a little puzzle. All right, let's go to the notes quick, and then we will be done. I think we're only doing through example 3, maybe. These are short notes because I'm separating 6-3 into 2 pieces. We're doing ortho-center tomorrow and the second half of 6-3 tomorrow. Okay, tomorrow's going to be a short day, and today is going to be kind of a short day. Let's do, I gotta find where it's at. Sorry, Remington, I'm making you dizzy. Nope, I'm in the wrong spot. Here we go. Okay, if you want homework, here's the homework. Page 369, 1 through 8, 10, and 11. Tomorrow I'll add to this list a little bit, but that's for now. 1 through 8, 10, and 11. Very nice. Good? 1 through 8, 10, and 11. That's the homework. I'll add some more to that tomorrow. Okay? Very good, very good. All right. Here we go. Let's go to example 1. Okay? All right, let's talk about what this means to be a centroid real quick first. This is my centroid. So, that means that if I'm looking at like this bottom side here, this length is the same as that one. Yeah? Okay? Like this guy is cutting this into 2 equal pieces. This one and this one, right? Is this angle the same as that one? Are those top 2 angles the same? No. And it's a little bit more obvious to see in this diagram, right? Like this right side looks longer than, or the bigger than the left side, yeah? Okay? This side will be the same as that one, right? It's not necessarily cutting this angle into 2 equal pieces, but it is cutting the middle of the side, right? This side will be the same as this one. So when they ask you questions and they say like this length is 7, right? That means this length is also 7. Like you can conclude these things. Got it? Sure? Okay. All right. BL is 6. B to L, the whole thing right here is 6. They want to know what BP and PL is. The whole thing is 6. What's the short and the longer segment?
3.
2 and 4.
No, same thing.
2 and 4. One of them has to be double the other one. Okay? If you take the total and divide by 3, that's what the short one is. 6 divided by 3 is 2. Then double that, right? Okay? This is like too easy. BP is 6, or BP is 4, PL is 2. Yeah? Okay? Let's do the check real quick on the next page. Top of the next page. It says BE from here to here is 9. They want to know what BQ and QE is.
6 and 3.
3 and 6. Yep. So BQ is the longer one, 6. QE is 3. Got it? Yeah, not too bad. Okay, example 2. This is a centroid again. You can see because each side is like split in half, right? So that tells me that this guy is the centroid. And PY, this little bit right here is 7. They want us to find LP. 14. Now be careful that sometimes they will ask you for the whole thing, right? So be careful what they're asking for. They're asking for 14, but if they ask for the whole thing, that's 21. Make sense? So be careful what they're asking for. This one is asking for 14, but just be careful, okay? Let's go to check at the very bottom. This guy, SP, this little bit is 3.5. They want PZ. 7. If they ask for the whole bit, 10.5. So be careful what they're asking for. But they're asking for just PZ, so 7. Got it? Yeah, not too bad. All right, this is the hardest part. Finding a centroid on a coordinate plane. All right, we are trying to take these 3 coordinates. I'm not going to read the whole paragraph, but we're going to plot those guys down at the very bottom here. Okay? So this little piece of graph paper, put those coordinates 1, 1, 11, 5, and 7, 10 on there. Go. Now connect the dots. There you go.
So we have to do the distance.
No, not quite. Not quite the
From
distance.
the middle, right?
We'll have to do the midpoint.
Oh, so you'll just average.
Yes, exactly. Yeah. So what I want to be able to do is I want to find the midpoint of this side and connect him back to like there somehow, right? So how do you find the midpoint of like these two coordinates?
You add them.
Yeah, midpoint is like average, right? I'm averaging them together. So 1 and 11, if I average them, I add them together. 1 and 11 is 12. 12 divided by 2 is 6, comma. 1 and 5, if I add those together, that is 6 divided by 2 is 3. 6 comma 3, I think is that point exactly right there. That's the middle. Okay? And we're going to connect him where?
To the opposite vertex.
To the opposite vertex. You betcha. Okay? Now we got to find the midpoint for all the other ones. Am I going too fast? No? Okay, let's find the midpoint up here. So I'm doing 1 and 7 is 8 divided by 2, 4, comma. This one's not going to come out nice. 1 and 10 is 11. 11 divided by 2, how much is that? 11 divided by 2. 5.5, 5.5. We'll go with the decimal, 5.5. Good. So 4 comma 5.5 is like this spot right there. And we're going to connect him back to this corner over there. Okay. Ooh, I didn't want to do that.
Hashtag relatable.
No. Okay. All right. Last one. We're trying to find the midpoint over here. So 7 and 11 is 18 divided by 2. 9 comma 10 and 5 is 15 divided by 2.
He's gone. So
7.5. 9 comma 7.5 I think is that point right there. And we're going to connect him back. Okay. Hey, they all kind of met in the ish spot. What's that spot called, by the way?
centroid.
The centroid. Okay, now, I like the centroid. This is my favorite one, but it does make graphing this kind of weird because we don't just get to guess where that point is located. We can actually find it. Yeah? Okay, so here's the deal. I'm going to focus on this segment right here that goes across. You could pick any one that you want to, right? But I'm going to pick this one. If this whole length is 9, right? This guy is 3 because it's a third of that, right? It's like a third of the way. Okay, so here's the deal. This distance is 1/3 of the way across, right? So here's what I'm going to do. I'm going to look at 4 and 11. How far are you going to the right when you start with 4 and go to 11? From 4 to 11. I'm going to the right how many units? 7. Okay, I'm going 7 units. But I want to go just a third of that, right? To find where that spot is. So I'm going to take a third of 7. Okay, if you take and do that, a third of 7 or 7 divided by 3 is how much? I don't know why it does that. It never used to do that, but now it like times out. Okay, I want a third of 7.
7/3.
7/3, 7 divided by 3 is
2.133.
2.3. We'll just say 2.3. We'll go one decimal place. 2.3. All right, now, to find out where this coordinate is located, I want to go 2.3 units to the right of this point, which will land me where? 2.3 units to the right of this point. 6.3 comma something. Do you see how that works? We don't know what this guy is yet. We haven't done him yet. But if I'm going 2.3 units to the right and I'm starting at 4, that'll give me at 6.3. You got it? Okay, now let's look at the difference between 5.5 and 5. I've gone down 0.5, right? But I don't want to go down 0.5. I want to go a third of that distance, right? Because I want to go over a third, right? Okay, a third of 0.5. 0.5 divided by 3, or 0.5 times a third, is like 1.17. Yes? Okay, or not 1.17, 0.17. So instead of going down 0.5, I want to go down 1.7. If I'm starting at 5.5 and I'm going down 0.17, where's that going to land me at? 5.5 going down 0.17. Or 5.5 subtracting 0.17. 5.33. Do you see how that works? That was kind of ugly. That was kind of an ugly mess. But we found basically exactly where that point is located because we know it's a third of the distance. Now, we could have gone this direction and gone this way, right? from 6 to 7 is 1 unit, right? But I don't want to go 1 unit, I only want to go a third of the way, which is 0.3, and that lands me at 6.3. Do you see that? From 3 to 10, that's 7 units. But if I take a third of 7, that's 2.3, and if I add 2.3 on to 3, that'll get me at 5.33. Does that make sense? So I could have done it with any of the medians, I just did that one because it was easier to look at straight across. Got it? Okay? What a mess. Yeah? Okay, you have one that's like that, I think. Maybe two. Maybe two that are like that on the homework. Okay? But the rest of them are really straightforward. Okay? So attempt those. Try and see if you can figure out where that centroid's located. Okay? Got it? That's all I have for you for today. 1 through 8, 10, and 11. Good? Okay. Goodbye, Remington.